What's up, YouTube? I'm back. So we're working on swapping out the rear end housing for the Patina car. It had a back in the day, a few years ago, we'd use the Rhodes parts and assembled housings in-house, you know, just buy their parts and pieces. I got axle tube local because I got a good metal supply, and so we would put the housings together. So the Patina car always had one of those housings in it. So now that we're so far in on making housings, I'm like, I gotta have my own housing in the car. Just can't tolerate it. So we are swapping it over. I have also engineered this new housing perch that uses a adjustable center that basically makes it so the housing perch is two pieces. It being two pieces makes it so you can change the pinion angle. So this car has an adjustable front box in it. It has adjustable slider locations. I now have two 75s for it, and I have two 95s for it. So I've got two size, wheels and tire combos for it, drag and drive, and for racing like we're gonna race that 530 index at Street Car Super National. So if anybody wants to check this stuff out, we will be there with this stuff. I'm gonna bring some swag. I got some new hats. I got 20 of them in stock, and then I'm gonna bring shirts with me and stuff too, so it should be cool. So I just wanted to kind of like go over what we got going on so you can see what the process is. I'm gonna halfway make this I'm probably gonna make a separate pinion angle video because I get asked all the time about setting up pinion angles. Maybe I have a different view, maybe I don't know, we'll see. I'll put that all out into a YouTube content format so you guys can kind of see what the thoughts are and you can make up your own mind from there. So let's flip this thing around. So here is the old housing. It's still a nice piece, has the through bolt perches on it. I'm actually going to sell it. I don't know that anybody could ever use it. It's goofy. It's 39 inches end to end, and yeah, it's not very wide. And the spring center line on it's like 27 inches, so it's not very big. Here we go. So here's our new housing right here in place. There's the new housing perch, so you can kind of see how this works. So this base plate right here, press broke, has these two tabs welded into it. It's actually tab and keyed right there. We figured out that we need to actually make some clearance for the center pin. The center pin doesn't fit currently, so we have to make a little change there. Then this tab welds from tangency to tangency around the housing tube, and that'll get two of those pieces. I got these 7/16 grade 8 12-point bolts for clearance, 12-point nuts, all the stuff in there. I welded this thing all together with a 20 thou shim inside of it, so this block will come back out. So basically what you've got going on is this is separate from that. So now this block, I can move the bolt hole locations in the block, rotate the housing this way or rotate the housing that way from center. So I made these blocks currently are on center, so I want to be able to get this all set up. So we ended up having to do a couple little back brace modifications there and to make that thing fit. What's cool is so imagine that if you have your center block, if you got a 1 degree offset, it go 1 degree up or 1 degree back. 2 degrees, it go 2 degrees up, 2 degrees back, so on and so forth, right? So I don't think that, I'm not gonna plan on going past 5 degrees. I mean, that's a 10-degree swing, +5, -5 kind of thing. So if you've missed it that far, you probably need to be cutting the stuff off and trying again. So right now you can see we're gonna move this thing around, right? I got that set up. I've still got plenty of clearance there to be able to move that to where I need to move that to. Okay, so here we go. They just got these little angle cube guys. They work really great, magnetic. You can see it up there. See right now that thing's set at 1 degree. I just wanted to point out that this is easily manipulatable from here, right? Can roll that thing to 1.55 now, right? So what I want to do is go over here, measure the crankshaft dampener, right? So I'm going to stick this guy, the magnetic edge, right there on the crankshaft dampener. And you can see right there we're at 0.15 degrees. Now I know that that's actually pretty darn close because I put the engine in this car at 0. So when we had it on the fixture, the engine and transmission's mounted at 0 as far as in relationship to the rocker panel. So what are we at? I floated up to 0.2. You're always going to kind of see a little bit of movement there with that. 0.25, 0.2, 0.15, right? So we're going to call this thing 0.2. So we know that we're actually super close. So here's the deal. Okay, so I just showed you, we measured the crankshaft dampener, it was at 0.2 degrees. I'm gonna use, just for this demonstration's sake, the engine and transmission is supposed to be in this car at 0, right? But since we've got it sitting on a 2-post rack, right? It's not perfectly level. So, but for just talking sake, crankshaft's at 0. That means the transmission's at 0. The U-joint plane is at 0 degrees, and now our pinion is also at 0 degrees. So our two U-joints would be parallel to each other, right? So I hear lots of people talk about negative pinion angle, like, so you'll see a guy write on the forum, -8. Well, -8, what? In relationship to what is what I should say. So equal opposite, as we know from the geometry, is what makes it so the elliptical orbit of a U-joint cancels out at the front versus the back, right? So you have one U-joint speeding up and the other one speeding up and the other one slowing down, the other one slowing down, or vice versa, right? So they're non-constant velocity. So when you put them in equal opposite angles, you have the planes parallel, and now those non-constant velocities cancel each other out. That's the whole idea behind it, right? So that's what you're doing when it comes to equal opposite angles. So if I was going to tell somebody, hey, set the pinion angle at -8, that would be 8 degrees below equal opposite, right? Well, I'm not going to ever do that because -8 degrees like vibrates like crazy. So this car actually had, by the time I got the ride height sorted out and changed a number of things, this thing had 6 degrees aimed downhill, so 6 degrees under the equal opposite angle, and it vibrated horribly. So vibrated like 40 miles an hour and vibrated like 140 miles an hour. In fact, I never went over 140 in it because how bad it vibrated. So we went like 880 coasting in Vegas at LS Fest, and it was like 140 something was like a quick, the most mile per hour. I was just like, dude, I'm not running this thing out anymore. It vibrates so bad. So developed this perch for 2 reasons. It makes it so, let's check this thing out real quick. This front box got these 4 holes in it. So what I did is I made a model in the computer that has, these bolt holes are on 1-inch centers. So it's actually the same thing as like the S10 box that I make, and it's the same thing as the OBS and NBS boxes too. You have 1-inch centers. Now the length of the spring from here to here changes that slightly. So the longer the spring, the angle change is not as drastic. I used a S10 length spring and a GM Nova style spring, not a Chevy 2, like a Nova style spring when I was doing the math. And I found that every one of these holes is about 1.05 to 1.1 degrees, depending on the length of the spring, right? So it's kind of easy math just to say every hole you go here, you need to move this guy 1 degree in order to maintain that pinion angle. So you could see if you were all the way in the bottom and you went all the way to the top, a 4-degree swing is a lot. Like that might actually put you on the opposite side of the equal opposite line, right? So you might be, I would be 0 degrees at the engine transmission, and I would be +2 sticking out the top of this thing, right? So when I had spring wrap, I would actually go, I would be going the wrong way plus some. So the motivation here was to make it so I could set you up with a perch that you could adjust for this hole size right here. We also now have some 12-inch wheels and some 14-inch wheels. The 14-inch wheels and the 295s are specific for doing the drag week stuff. And then we got some 12-inch wheels with some 275s for doing kind of that, I was just talking about running that that 530 index, because that's as fast as, the car's gonna, I think the car with the right turbos will run 480s, but I don't have the right turbos for it yet, so 530s is kind of a good spot to be. It makes me so I can test some more stuff, make sure some things work. But it'll make it so if I need to move this bolt hole to adjust ride height, I will also be able to adjust this block in the center, right? Having a different, that aluminum block that's in the center has a different location for the holes, and I can rotate that pinion up or I can rotate that pinion back. So I have a centered block right now. I'm gonna set this face at my old settings. I'm gonna set this face at 2 degrees below, so 2 degrees negative, which would be 2 degrees below the equal opposite line. So I'll have 2 degrees of built-in angle for the spring to wrap up, and then from there I'll be able to move this. This will be on center at that 2 degrees. I'll be able to go up to 5, behind 5, and then on 1 degree increments from there. So hopefully that makes sense. This is also going to allow for me to do some apples testing on pinion angle. Like once I get the car sorted out and I know what it's 60 foots and I know that it works well, then I can go in here and be like, I'm going to put 2 degrees of extra pinion angle in this thing and just swap the block at the track. So get an A pass, go back to the pit, swap the block, make a B pass, see like, yeah, hey man, that picked up this much in 60 foot, or this picked up vibration, or this didn't change anything, right? So I feel like this would at least be somewhat scientific to be able to actually test it. So yeah, here we go, man. So we'll be, like I said, this is, I'm gonna keep on going, covering what we got going on here. our little pockets. We can get to the bolts and get the bolts out, 12 points, 7/16. This all still worked out good. Be the same through bolt style deal. Regular hardware fits in there. It will probably end up with a nice 12 point in there, an NAS. I've also got a doubler spacer in there, but I don't know if I'm gonna be able to make it fit. It's really close on the bolt heads, so I will, to be continued. I will let you know as we go. All right, so I forgot to do a bunch of updates during the week while we got this rear end housing together. Admittedly, it was just crazy busy. Lots of stuff going on. We made a bunch of racks and stuff for the seismic conduit holder thing, whatever. There was 166 of them, so, and we made them pretty much all this week. So it was just a gnarly week. So anyway, I am here because working on the Patina car again. I want to give you some more updates. So the ride height is jacked because it's still too low. So this front spring segment, let's walk over here real quick. Let's do some more insight. So as you guys remember from the earlier videos, I've been like chopping up springs and moving things and doing things and whatnot. I was running this segment right here. This is a S10 front segment, and we re-drilled the hole to there from there. And then you can actually see the impression of the housing perch right there. Right across right there. So we re-drilled it to there, filled in that hole. And then the bottom of the old housing, which is right here, the hole in the bottom of the housing is way at the front, right? It's right there. So you can see how much we shifted. It's like 2¼ inches is what it worked out to be that I shifted the rear end rearward in the car. It's probably asking me like, why the hell did I do that? Well, because I wanted a little longer instant center. I wanted a longer spring on the car to try a few things. And when I tied this #1 cross member in, I wanted this pocket to not be 9 inches long. It wouldn't be 9 inches long. It's an exaggeration, being a little hyperbolic there. But I would have had to have been more inches this way to use that factory spring length. So I really wanted to tie this in to this #1 cross member. I felt like if I could get a longer eye to eye on the spring, I could get more droop out of the spring. I could put a longer spring on it with more arc, get more extension travel from ride height, and then still have some bump travel to be able to drive the thing on drag week to make it comfortable. So you can see that the pinion angle is way better now. To fix, but that's the reason why these springs are so long. So I really wanted to be able to do that. So this back section of this guy is a Silverado spring because I had an OBS truck, not a Silverado, OBS, that we chopped up and turned into a race car, and had the springs left over. So this eyelet is a bushing that I already have. So I just chopped this thing up and did this. Well, what ended up happening was it wasn't enough. Like it wasn't enough spring rate. The car just would sack out and wouldn't hold itself up. So we ended up chopping up the Chevy 2 spring, the stock mono leaf, and then put those in as a secondary spring, and that worked. That actually got the ride height kind of where it needed to be, and it supplied 6 inches of extension travel. It was actually pretty cool. Everything worked out great, but I didn't like the fact that this main spring only went to the edge of the housing right here. There was no overlap. So I wanted to get some overlap. My hopes were is that this stiffer front section would allow us to ditch that secondary spring in the back and to put it on the ground last night. And nope, it didn't work. So tentatively, I could put those other 2 pieces back in, or I'm gonna try the back segment of my factory Chevy split, my factory Calvert split rear section. I'm gonna put that on there real quick, slap the wheels back on. It's just impact gun work, and kind of see where that thing lands from there, and then I'll update you from there. Little heads up on this stuff, when these springs are 2½ inches wide like this, you might have to do some sanding and love because this stuff ends up being really close. It's just part of the game, right? Okay, there's my update. Yes, I'm not on the computer. I'm out here working in the shop. How about that? That's right, getting dirty. Okay, I got the Chevy 2 spring up there. You can see that it is really far back in the slot, especially with it just hanging here. That's lined up with the hole there, all that good stuff. So what's cool is I got a bunch of carbide tooling. So you can see that this clamp is pretty close right here. I'm just gonna go, got my tape measure out and just loosely said, hey, I should move that 2 inches. So I'm gonna re-drill this hole right here 2 inches this way, so the spring slides further forward and is in the slot more appropriately. So, okay, I'll report back in a minute. All right, so just to give you guys an idea, factory, when I say factory, that's funny. So a Calvert -1 rear section of a Chevy 2 spring overlaid on the Silverado spring. You can see the difference in the arc right there. So I'm convinced this thing's not going to have the same amount of extension travel with the spring, but I'm going to see if it'll even hold it up. So I'm going to start off there and then see what that looks like. So it's spring deconstruction day here at Funkhauser Race Cars. Yeah, check this out. So if you have real carbide tooling, this is like a, I don't know, $35 drill from Haas Tooling that I use in the mills. Has a ground shank on it. That's really nice and concentric. Then I put it in this cheesy ass old school Jacobs chuck in my $100 drill press I got off of Facebook Marketplace, or Craigslist. It would have been Craigslist back then. Craigslist, you know, I think I've had this drill press for 15 years now, which is funny, but you can see how easy this thing drills. Got a little bit of coolant in there. It's not spinning very fast. I didn't bother to calculate the surface feet per minute because I know it's not very fast. Carbide in this hardened material, you could probably go, I don't know, 150, 200 surface feet per minute. So you can see it's just drilling it like effortlessly. Throw a little coolant in there. I'll put a link in the description for a surface feet per minute calculator. Right, that's the reason that these drill presses have all these different speeds, is to make it so you can, you can spin the drill at the right speed. So you can hear that thing's chopping those chips away, not squealing, drilling really, really nice, right? Nice even pressure. Throw a little more coolant in there. Bam! Easy peasy. Okay, I'm back. It's been about an hour and a half. I drilled those holes. I got sidetracked, I was doing something else, but I went ahead and took a measurement to the bottom of the car with that old round, that other spring, the other spring that was on it. So I measured from that surface right there to the bottom of the spring pack, the top of the spring pack. And we got 15 1/4. It was 16 1/4. So the rear end, does that make sense? So before it hung 1 inch lower to the top of this spring arch right here, which the top of the spring is the bottom of the housing. That meant that the housing was 1 inch lower than it was before. So I lost 1 inch of extension travel putting this Calvert rear section in. Interesting too, this lower section, way thicker. Like in fact, this, I don't even know how I'm gonna get a bolt in there. That's probably gonna have a 1/4 inch bolt next. This spring section weighs 15 pounds, and what I took out weighed 14 pounds. So it's 1 pound lighter, but it's also like 5 inches longer. So when you jump up and down on that thing or just hop on it gently, like it's really springy. This one's not very springy. So I'll be interested to see what the ride height does here. I really want to try to go to Bakersfield next weekend, so I kind of like stuck a little bit, but maybe what I'm thinking is taking those springs right there and my other spring that I had arced in there, because there's 20 pounds worth on those other two. So basically you got 14, 28 plus 20, so you got 48 pounds for those two spring sections. These two are only 30 pounds. So that's, 18 pounds I'd love to lose out of the car because it's a heavy tank, heavy turd, and it's got a fat driver, which I only weigh 290 pounds now. I don't weigh 310 anymore, so I'm less fat. So it's gonna go faster with less fat. So, all right, I'm gonna get this thing down. Let's see, hopefully it has some ride height. Oh, so something lame is you used to be able to put the tires on with them filled up. Which, I mean, these are giant, right? Like 295s on these cars, that's a giant tire on a Chevy 2. In fact, you can see just like how far it really still drops out of there. But you used to be able to put tires on without taking the air out. Now you have to take the air out, which is so lame, but it is what it is. All right, well, that spring combination basically worked. So I might look at, I think we need to get some weight out of the back of this thing. It is like 55% on the tail. So that go into that aluminum motor, really lighten the front end up. So aluminum block instead of the iron block, 6 liter. So, I mean, it's still porky. So yeah, this thing is still porky. We need to get some weight out of this thing. We were just talking about it. So it's like 45%, 45.8% on the nose right now, which is cool if the track's really junky, but man, this thing, it's gonna wheelie if the track's good. So I don't really wanna wheelie and destroy things. I know it's way lighter because I had to take a whole inch of preload out of the front end, out of the spring. So I was like, dang, dude, this thing's definitely lighter in the front. So we were just bench racing some ideas. It does have 2 lead acid batteries in the back, you know, 40, 42 pounds a piece. So that's 80 something pounds right there that we could switch to maybe a lithium, or which I'm not really fond of. I don't really want to do that for a drag and drive. Maybe go to an Odyssey, like one of the thinner, smaller Odysseys. And then we're talking about maybe mounting it in the front end somewhere so we could shift some of that weight. So there's there's a good 60 or 80 pounds there to kind of play with. There is 18 gallons of E85 in it at 6.8 gallons per pound. That's about 119 pounds of E85. So that could definitely be changed. I never really finished making a plan on what we're gonna do for the whole fuel system thing. I think this motor, I got the dual injector intake, so I really wanna do a street injector, which I have in the manifold, and then a methanol injector, and then do all the fuel pump stuff in the front. So maybe I can start moving this weight bias around and get this all figured out. So yeah, I originally built this car, the motors moved a good bit here, backwards. I've showed you guys before in the video on that front plate, that bend in the front plate is the difference between the big block and the LS. I didn't build it with the idea of putting the LS in it. I built it with the idea of it having the big block in it. So the weight distribution would have been a lot closer with the big block than it is with the LS. So it's funny. I'd rather the LS motor be further forward in the car right now because I don't want to add weight to get this weight bias back together, but it's a long road to get this thing to 55% on the nose, right? So 10% of the gross vehicle weight, which doesn't necessarily mean anything as far as the entire, shift of the car from center line and all that stuff. But, 50 or moving 10% would be 300 pounds. So yeah, hopefully that's not really the case. So there we go. It's back on all 4 wheels. That spring thing did in fact work. It holds the car up. I might get the standard spring for the back instead, because that's a -1. So I might get that standard spring height back section, get myself an extra 1/2 or 3/4 of an inch of ride height back there. It looks cool on the 295. Everything looks good. So there we go. That's the end of the video. Thanks for following along. I'll catch you guys later.